keeping up? Now, if you have a rectangle, obviously a rectangle is a parallelogram. So if you have a parallelogram and a rectangle is a parallelogram, all the rules that apply to a parallelogram apply to a what? Rectangle. Because a rectangle is a what?
Parallelogram.
It is a parallelogram. So we know from just by the definition of a parallelogram that the opposite sides are congruent and the opposite angles are what? However, obviously in a rectangle, that not only the opposite sides are congruent, but all four angles are what? Congruent. Okay, so that's the main difference. All right, that the angles are all congruent, and if the angles are all congruent, that must mean that they add up to, or each angle measures 9 degrees. All right, so that's what makes a special parallelogram, is the fact that it has 9-degree angles. All right, so again, the same characteristics apply. Now, the next thing, do the diagonals of a rectangle bisect each other? Yes, because a parallelogram, when you have a parallelogram, the diagonals do what? Bisect each other. However, in a parallelogram, what do you think is true about the diagonal, or not in a parallelogram, but in a rectangle, what is true about the diagonals? Not only do they bisect each other, but they are what? They are equal. All right, and what I do is I try to visualize, or have you visualize what a rectangle is. And if you look, the diagonals are congruent. And then we said once you start to make it the angles less than 90 degrees, then one diagonal gets shorter and one diagonal gets longer. All right, so if you have a parallelogram, you have to know that the diagonals are congruent. And again, they might even ask you to prove that, which would be really easy to prove. All right. But let's just take a look and see how simple this is as we're going through. All right. So question number 1. It says an X brace on a rectangular barn door is both decorative and functional. It helps to prevent the door from warping over time. If ST is 3 13/16 feet, PS is 7, so let's just go ahead and write that out. I'll write it so I can see it. So PS is, well, I can't see that. So PS is 7. Which automatically would make what? QR would have to be 7. And then it says that ST, let's go ahead and mark that, 3 13/16. 3 13/16, which means that TQ is what?
3 13/16.
3 13/16, and what would PT be? Exactly, and TR would be the same. Does everybody agree with that? Because remember, we said the diagonals of a parallelogram bisect each other, so that means this is equal to this. And then we also said the diagonals of a parallelogram are equal, so that means those are all congruent. Is everybody with me on that? Then it says that PTQ is 67 degrees. So this right here is 67. So that means the vertical is also what?
67.
Did I do that wrong?
Is that your angle?
Oh, yeah, PTQ, thank you. So it would be this guy up here is 67. All right. So then we can just go ahead and come down here and say this angle is 67. And then what would QTR be? 113, exactly. So this over here would be 113. Now, obviously, you're going to have to figure out what these two angles are right here. Does everybody agree those two angles are the same? So the easiest way to do that would be to do what? That's exactly correct. Thank you very much. 180 minus 67 divided by 2. Everybody agree with that? And then to find the missing angle right here, you just do 90 minus whatever that angle is. Or you could do the same thing, 180 minus 113 divided by 2. Walker, what's the
How
problem?
did you find out 67?
Well, it told me it was 67. Right? Everybody good with this? All right, anybody have any questions? It's very simple. I told you, very simple. And even if I didn't tell you that, you should probably be able to figure that out. All right? So let's just answer the questions real quick. QR has to be what?
7 feet.
7. And then SQ.
7 and
SQ is what?
10. 7 and 10.
How are we getting 7?
No. It's 13. I got 6.
Yeah,
Go to
that's
7
right.
and 10 over 16.
Yeah, and then you divide by
I'm doing length SQ. Right? Let me make sure you guys are
It's
serious.
13 over
2.
16,
7
not
and
3.
5
Oh, is it 13?
13, not
I thought it was 3. That's what the problem is. I can't see that. Thank you. Yes. 13/16. All right, so you're right. Thank you. So then if I double that, right? We don't need a calculator for that, so let's practice. So it would be 6 and then 26 over 16, right? And then that would be 7 and 10 over 16, which is the same as 7 and 5/8. All right, we don't need calculators for that. And if for some reason you've forgotten your little fractions there, just let me know and I'll fill you in. Any questions on that? All right, now let's take a look at number 3. What do we say? TQR. TQR is obviously what?
33.
Wait a minute. TQR is how much? Is everybody okay with that? 33 point what? 33.5 degrees. Right. Again, you can just do 180 minus 113 divided by 2. And then what about TSR?
56.
What did you say it was? 56.5 degrees. Again, reason it's 50, yes. Okay, so here is the angle that we're looking for. Let me get rid of this. TQR is this guy right here. Right, I'm looking for this angle, right? Well, did you know how to do TQR?
I did.
So that's easy for you then, right?
Yeah.
Okay, so then if we're doing TSR, is this angle right here, right? Well, there's so many ways of doing this,
I thought we
right? This angle right here we know. This angle is 90, so if we wanted to, we could just say these two angles add up to 90 and subtract. Or we could do 180 minus 67 divided by 2. All right, lots of ways. Okay. Everybody okay with that? All right, now let's look at the next part. FD is 3x minus 7, and EG is x plus 5. So what's true? They're equal. So let's just do the mental math on that and tell me what x equals. I think x equals 6. Everybody okay with that?
that EG.
Now again, on the test, the reason most people make mistakes is they just solve for x and don't answer the question. It could say x equals 6, and that might be what we have to need, all we need. But they're asking for EG, which is what?
11.
So EG is equal to 11. All right, now let's look at question 6. EFD is 2x minus 3. And then DFG is x plus 12. So they equal 90 degrees, right? So what is that? 3x plus 9 equals 90, right? So divide by 3, x plus 3 equals 30. So x is equal to what? I got x equals 27. Now it says EFD.
Oh.
So what is that? 51 degrees. Anybody else get that?
Yeah.
51 degrees. Bless you. Yes.
How did you get it equal?
Well, what are we talking about here?
How do you get
No, I'm saying, what is the shape? What is the figure we're looking at?
a triangle? Oh, I mean a rectangle.
Thank you, Walker. It's definitely a rectangle. So that angle is what? How many degrees?
90. But what about the
This is 90 degrees right here, right?
yeah.
So those add up to 90.
Oh. I see.
You good now?
Yeah.
All right.
I see.
Thank you. All right. Now, number 7. Here we go. It says, if ABDE is a rectangle and BC is congruent to DC, prove that AC is equal to EC. All right, so now again, this right here is the important part. So here we go. Let's give it a shot. What I want to do is I'm going to go ahead and just pull this down.
To the bottom?
Yep, I'm going to put it down at the bottom here. And then over here, come back and get the picture. All right, let's see what we can do. All right. Again, guys, I think you should be pretty good at this. All right. Nothing about a proof is that hard anymore. All right. Statements, reasons. Number 1. All right. We know that it's a rectangle. All right. So A, B, D, E. Now that's important. Is a rectangle. And that's given. And then it also says that BC is congruent to DC. Now I'm trying to prove that AC, I'm trying to prove that AC is congruent to EC. Bless you. Well, now that's really simple. All right, just someone tell me. We don't have to do it. I mean, we're going to write it out, but just somebody tell me how easy this is. What am I going to say?
AB is congruent to ED.
That's correct. What else?
And then angle ABC is congruent to angle ED.
Exactly. Then it's what?
Side angle side.
Then it's side angle side,
CPCTC.
and then it's CPCTC. Come on, guys. Come on. That is very, very easy. All right, very easy. All right, nothing difficult about that. I don't want to hear any excuses now about, oh, proofs are so hard. All right. So let's go ahead and finish it up. We're going to write it all out just to make sure. Number 2, I want to say this. I want to say that, and I'm okay with this, angle B is congruent to angle D. Now, why can I say that? All right angles are congruent. Now, in your book, the solution probably says angle B and angle D are right angles first, right? But why are they at right angles? Because it's a rectangle. Definition of rectangle. Everybody with me? All right. So if you want to put that before, that's probably what the book did. All right. So we can mark those right angles. And then the other thing he said was that AB is congruent to what? ED. Again, why is that? That's the definition of a what? A rectangle. Definition of a rectangle. All right. Rectangle states that opposite sides are congruent. The angles are 9 degrees. All right. So now I have that equals that. And so now for triangle what? Is congruent to triangle EDC. And that's by what? Side angle side. And then, that's right, AC is congruent to EC by CP, CTC. Corresponding parts of congruent triangles are congruent. Easy. Very easy. All right, so probably the only thing I did wrong here was didn't say that angle B and angle D are right angles. All right, so here we go. Let's scroll back and see where we're at. Okay, graph each quadrilateral with the given vertices. Determine whether the figure is a rectangle. Justify your answers. Now, if it's a rectangle, what's true about the sides?
Two sides are.
Yeah, but just because, listen to me guys, here's the important part. Just because the two sides are equal, does that make them a rectangle?
No.
They're all what?
Right.
So it says here, how is that going to help me with using a slope formula?
It's either extra long, shared over
That's right. To determine they're perpendicular or not. So it's a rectangle if the slopes are what? And how do you determine if they're perpendicular though? They're what? Negative reciprocals. Thank you very much. If they are negative reciprocals. So what we're going to do is I'm going to pull this one down and show you real quick. Just put that in the garbage. I don't care about that. All right. I'm going to pull this down. All right. And then we'll add all right, so let's make the X and Y axis here just so you can see it. Now let's go ahead and graph this. All right, -4, 3. And then 1, 5, 3, 1. -2. Is that right? It doesn't look right. -2, -2, 3, 1. 1, 1, 2, 3, 4, 5. Yeah. That's right, it just didn't look like it. So right off the bat, is it a rectangle?
No.
I mean, we can just pretty much look at it and tell. All right, does it say prove that it is, or does it say is it? Graph each quarter. Determine whether the figure is a rectangle. Okay, so we can easily verify this now. So here's all you have to do, guys. And look how simple. All right, let's do the slope of this line right here. All right, now again, I don't mind graphing it out because sometimes it's a little bit easier. The slope here, how much should I go up?
2.
And I went over 5, right? So the slope is 2/5. Everybody agree with that? So if it's perpendicular, the slope of this line will be what? -5/2, right? That's how simple. So let's see if that is. 1, 2, 3, 4 over 2. Slope is -4 over 2, so it's not a rectangle. Everybody good with that?
Yeah.
It's not a rectangle. That's how you tell using the what? Using the slopes. Thank you. All right. So now let's grab the next one and see what it says. All right. The next one it says using the what? Now, So here we go. Now, what are they referring to when they ask for the distance formula, though? What should you be checking?
The distance between how long you should.
Anybody?
The distance between all the points graph.
Yeah, but how do you tell the difference between a parallelogram and a rectangle? That's what I was trying to tell you earlier. Well, they want you to use a distance formula. So how do I figure out what distance are they referring to? How will I know if something's a rectangle? What distance?
Oh, the diagonal.
There you go. Thank you. Right? If the diagonals are congruent, then it's automatically a what?
Rectangle.
It's automatically a rectangle. So everybody with me on this? All right. So here we go. Let's graph this out now. Let's graph this one and see if it's any better. So 4, 3. And then what? 4, negative. Oh, wow. This one's too easy. -4, -2. Oh, wow. -4, 3. All right. So this again, if you're drawing out this rectangle, obviously now this one is a rectangle, but, all right, let's talk about it real quick. Because we want to reference, this right here. We want to talk about this here, and we want to talk about this here. It's a rectangle if those are what? If those are, yes, you're right, if those are congruent. All right, so personally, here's how I want you to do it. All right, we know what the distance formula is. Everybody can write the distance formula because that's coming up more and more on the SATs. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. But we don't need that. That's just something if you didn't know, all right? What we do know right off the bat is this length right here, this length up here is going to be what? 1, 2, 3, 4, 5, 6, 7. Is that right? 8? Is that good?
Yep.
And then this is 1, 2, 3, 4, 5, correct? Now, that's going to give me 8 squared plus 5 squared. Everybody see that? And then if I took the square root, that would give me the distance. Does everybody agree? Equals, now, this over here is 5 and this over here is 8. Does that equal the square root of 8 squared plus 5 squared? Obviously, do I have to do any more work than that? No, I don't. So yes. How do I know? Because the diagonals have to be what? Congruent. If the diagonals are congruent, then it's automatically a what?
Rectangle.
It's automatically a rectangle. Is everybody good with this? I don't think that's that hard. All right. Do you necessarily have to draw it? No, you don't. You don't. You can just say that AC is a diagonal and BD is a diagonal and find those distances. And guess what's going to happen if you do x minus x? You're going to get what? And what happens if you do y minus y? That's what we did. Come on, I really want you to try to listen to what I'm saying up here. And if you're not understanding what I'm saying, I want you to tell me. Does everybody understand? If I do x minus x, I'm going to get what? 8. And if I do y minus y, I'm going to get what? That's how I got these numbers here. I subtracted the 2 x's. But instead of subtracting, I just did what? I just counted and graphed it. That's exactly correct. So I'm trying to tell you, when you forget the distance formula, it's super easy to figure out what the distance formula is. If you understand the distance formula is nothing but the Pythagorean theorem. That's all it is. So I've agreed, that's pretty easy. All right. Now again, guys, I've told you now, we're in what, November. I have a week off in November. I have a couple weeks off in December. Is everybody hearing me? I'm trying to tell you guys we don't have a lot of grades. So, and that's what I want you to realize when you're whining about other classes, it's hard to get your grade up if you bomb a test. Right? So you have to stay busy. That's why, listen, sometimes, I want you to do the work that is necessary for you to maintain the grade you want to maintain. All right? That's why sometimes, checking the homework is not the easiest thing for me to do. Because I'd rather just demonstrate everything to you. But at some point, you have to make sure you're doing the work. Right? And some of you are teetering on a 90. Right? And you can make, so understand, you can make 2 A's in quarter 1 and quarter 2 and get a B for the semester. So understand that, right? If you're a person who likes to be 90 average, if you get below a 90 on your exam, that means you're below a 90 average now. All right, that's why I'm trying to tell you, keep up with the work. You're not doing yourself any favors by just saying, well, I can just do a little bit. It's no good. All right, get all the work done. All of this is important. The proofs are easy. The proofs are easy because you've done the proofs. The proofs are hard if you've never worked on a proof. You've always waited for me to do the explanation. You have to do it. All right, find time. And now it's time. I'm done. Finish up. All right, draw things out. I like the iPad because it makes the graph easier. All right, get to work. No excuses.